Hi, my name is Noah Gift, and today I'm going to talk about AWS storage systems. We're going to talk about the Elastic Block System, or EBS, also S3, the object storage system, which has unlimited data storage, and also EFS, the Elastic File System, and finally offsite backup and also archiving systems with Glacier. We're also going to do some demos of those products. Let's go ahead and get started. So in terms of storage, we're going to cover Elastic Block storage, which is the thing that attaches to your machines. Talk a little bit about S3. We'll also talk about Elastic File System and then Glacier. And then, yeah, I'll do some demos of these as well, because I think they would be helpful to everybody. And let's get into here. So in terms of core services, we talked a little bit about the VPC already, right? That's the virtual private cloud. That's where you can isolate everything and make it talk to each other. The EC2, that's virtual machines, spot instances. And in particular, though, we're going to cover object storage S3, the block storage EBS, the EFS, which is Elastic File System, and then Amazon S3 and Glacier, which is both, Amazon S3 Glacier, which is essentially like offsite backup. So let's start with Elastic Block Storage here. And Elastic Block Storage, a couple things to remember about this is that this is a type of storage that you can attach to a virtual machine. That's why people use it. It doesn't attach to multiple machines at the same time. That's probably one of the key things to remember, but it is persistent. So you can actually remove it from, let's say, a virtual machine and then attach it to another machine. So this is a really good graphic right here. Like, well, why do you care? Why would you want to use block storage versus object storage? The big takeaway here is that with block storage, you can incrementally change something, right? So you could have a file that's a terabyte file, and that terabyte file, you just want to change the first line. You can go into block storage and just incrementally make one change. And so that is a huge advantage over object storage in that particular example. So if you wanted to go and update a 1 gig or 1 terabyte file on Amazon S3, you have to actually pull it down, download it, make a new version, and then upload it again. So that could really be expensive in terms of the network. Like, imagine if you're at Starbucks I used to live in the Bay Area, you're at or a Blue Bottle of coffee or something, and you're like, look at this. Ooh, like a terabyte. You don't want to do that on the coffee shop, right? You have a problem now because you have to change the whole thing at once. So there are other advantages to object storage, but if you do have to make incremental changes, block storage is the way to go. So EBS enables you to create individual storage volumes, attach them to an instance, and the volumes are automatically replicated as well. So basically, one of the things that's nice about this is that, if you remember, availability zones are different data centers. You don't have to worry about that data just disappearing. That's a huge advantage. And in addition, it can be backed up to S3, which is really awesome, right? Because you could have snapshots of something you're working on. If it's a really important project, or a capstone project, or maybe some kind of consulting client project, or you're collecting data for a research project, it would probably be a good idea to incrementally make snapshots of the EBS and then put those into S3. Some of the things you would do with the EBS, block volume storage, you could do data storage for a file system, you could do database hosts, enterprise applications. So here's an example of some of the volume types you have with a SSD drive. So if you have a Mac, I think a lot of people are super into Macs. I'm into Macs. A lot of Macs have SSD drives, and the reason why you want to use an SSD drive is that it's not a spinning disk. Like, you don't hear it spinning, it's memory. And so it's extremely fast. And as a result, you can get extremely fast disk performance. So in this case, if you look at the word IOPS, what this means is essentially like how many times you can make requests back and forth So in this case, you could make, in theory, up to 16,000 requests per second, which is very fast. I mean, ridiculously fast. Like, I don't know what, off the top of my head, what a 8K video performance would be, but I think it's like a few hundred requests per second. So you can have incredibly fast performance in terms of the SSDs. Now, the way this works, which is kind of interesting, is the bigger the storage volume, it'll automatically give you more disk I/O. Now, you can as well provision like an EBS volume and say, I need this to be as fast as possible. And look, you can even make it 64,000 IOPS per second. And you can see that it would be 1,000 megabits a second. So there are some really, really high performance things you can do with SSD on EBS. The other thing, by the way, you can do that's kind of a little bit of like a hidden menu of EBS is you can also stripe multiple volumes together. So you can actually make them all a huge volume. And at each one, you could combine the throughput of all of the volumes together. Now, the hard disk drives are literally physical spinning disks, right? And so they're much, much slower. Look at this, 500 inputs per second, or cold is 250. So you would use this for things where you don't care about disk performance, because you get a big deal on the pricing for the storage. So here we go, solid state drives. It would be general purpose. It's recommended for most workloads. System volume, boots, virtual desktops, low latency drives, desktop and test environments. For provisioned IOPS, this would be something where you would have maybe like a database, like a really high performance database, like a custom graph database or relational database for maybe a client that you're working on that has to be, very, very performant. For the hard disks, you could do streaming, like where maybe you don't care about looking at the data, you just want to write it somewhere. For big data, so if you're using Spark or Databricks or something like that, where it's going to use lots of different machines, then you would combine the speeds, because you would combine all those different machines together. Data warehouse is another good one. Log processing. This is a very common one, is if you're going to write logs from web services. So many companies that are running web services, they'll keep track of who has visited their website, and they may put those logs onto a disk, and they wouldn't want to put it on necessarily like a really high performance disk, because you're just archiving the data. But then later you would run some process that would aggregate those logs and do some kind of analytics. Cold, this would be for maybe infrequently accessed data, but you want to maybe keep it around, but you don't want to spend a lot of money for it. Again, maybe it's some kind of research project or data collection job. So some of the features of EBS would be point-in-time snapshots, which is very, very nice, right? Because imagine you have a server and it's got all kinds of things configured on it. You can just keep making snapshots of it. And if you accidentally messed it up, like you installed the wrong things or you corrupted something, you can just go back in time and redo it. You also can encrypt the EBS volumes as well, which is pretty interesting, because if you did have some project where that was a requirement to have your data encrypted, you can actually do that with EBS. And then this is also kind of a stealth feature of EBS, is you can actually just right click on it, you can detach it and then resize it and then reattach it right onto the machine. So it's pretty nice, is if you accidentally messed up and you're like, I only made a 100 gigabyte disk, what do I do? It's actually not bad. You just stop the machine and you can resize the EBS volume and then reattach it, and then now it's got a huge disk. So it's actually pretty straightforward. So EBS volumes persist independently from the instance. All the volume types are charged by the amount that's provisioned per month. And then the general purpose is you're charged by the amount that you provision in gigabytes per month. So basically, general purpose, you're not necessarily specifically configuring like how fast it is. It just gets faster the bigger it is. Provisioned IOPS, you're actually charged by how fast you make it. And so it is more expensive. That's probably the most expensive kind of storage you could offer. And then in terms of snapshots, you would just be charged by the gigabytes per month. And then data transfer, if it's inbound, it's free. But if you're going to other regions, there would be a cost associated with it. So here's the takeaways. It's persistent. There's both the HDD and SSD. It's replicated in the same availability zone, or AZ. You can do encryption. You can make the volumes bigger or smaller. You can also do backups. So these definitely, for a certification exam, you got to know all these items. So for EBS, yeah, let's do it. Let's do a demo. Let's go into here. So how would we do EBS? Let's go into EC2 here, and what I can do is just spin up some machine. Let's go to an instance, and I can just maybe launch an instance here, and then it's going to ask me what kind of instance. Sure, let's do this one, Amazon Linux 2. We'll select it, and we can pick one. Look, it says instance storage EBS. I'll just pick a really small one here, and I'll go to configure instance details, and so we'll just say 1. I won't do spot instances because I'll be lazy here. This all looks good, and I think I can do. Yeah, let's just keep going here. So it does say file system, add a file system, but we're going to add the storage here, which is volume type. Notice how it gives us these options. It says you can basically decide what kind of storage you would like this to have, because this is EBS based storage. We could say I want to do the general purpose, I want to do provision IOPS, or I want to do like the really slow one. And so you again have a choice here. We could make this a little bit bigger, and then you could also add a second volume if you wanted to. You could also go and say, hey, let's make another volume, and I'll delete on. And this is interesting too, is that you can select delete on termination or leave it. It really depends on what it is you're trying to do. But if you don't select this, you could get yourself into a little bit of trouble, because you're going to be charged for this volume once you delete it. So I think if you're a student, probably a good idea to leave this. And then again here, you could actually encrypt it if you wanted to as well. So you can see all the features, right here, just by playing around with it. And again, you could pick what volume type, everything. So we could go here, review, and we could go through the security groups, and we can see SSH is set up. And I think I have the SSH. Yeah, I think we should be able to just launch this. Although where's the part where they do the keys here? Let's see here. Review and launch. That's good. That's good. I don't see the part where they let me do the SSH keys. It might be in here. I don't know if I need the SSH keys actually. I don't think I do. But let's just launch this thing. Let's try it out. Oh, here we go. So it did ask for me. So I think I can choose an existing one, and I forget when I created one. Demo February. That looks good. I think that was probably one that I did before. Hopefully I have that on my machine. But the idea here is that once you've launched this thing, that it's not only going to have the boot volume, but it would be whatever volumes additionally that you would want to put on inside of the machine. And what's not kind of nice about it is that if you wanted to, you could always detach that second volume, and you could do something with it. Like you could put it to another machine. So if you were doing some kind of work where you were collecting data, you could potentially put the data onto the second volume, do some kind of operation, and then detach it, and then maybe even make a backup of it, and then attach it again. So it's really like a portable storage system. So especially for like data science type programs, I think it is not a bad idea to know about, you know, how to use these things. It was just the fact that you can detach the EBS storage. And so this thing is, I think, waking up here, and let's look for running. Okay, this looks like it's running. I can try to connect to it, and I think I can just connect right here without even, I don't even need to do the key. But if I do a df command here, and I do a df, what df does is it shows you all of the mounts on your machine. And so we should have multiple volumes. So we have the boot volume, which is here. That's the root. And you can see it's got 8.5. But if I remember correctly, you have to explicitly mount the second EBS volume. And so if I remember correctly, the way you do that is, let's double check here. Let's say mount EBS volume. This would be Amazon Linux 2. There should be some instructions here. You have to run a command. Let's see here, that'll tell us how to do it. So it says, okay, make an EBS volume available. So what you do is you connect to your machine and you run this command. So we can run this. We can run this lsb block. Okay, let's do this command. And what does it give us? And so what it'll say is this: the following is an example for a T2 instance. It has one partition named XVDA. The attached volume, which has no partitions, is not mounted. So I believe this one, so it should have one that's actually not mounted, right? Because you see how there's two, right? This one is actually, I believe, not mounted right here, because this is the boot here. And then there's a second one. So this one is XVDA. So that's the one that's in use, but this one's not mounted. XVDB. Yeah, XVBD. So now what we do is we say there is no file system on the disk. So we can basically do this. We can run this command right here, which says sudo -s, and I believe we do this. Cannot open, is that correct? Yeah, if the command, if the device has a file system, so I think it says that there's nothing on there. And so what we want to do, if you discovered there's a file system, skip the step. But basically we want to do this. We want to make a file system for that empty volume. So we want to do this. We want to do this. We want to make a file system for that, which is XVDB. XVDB. There we go. And then the next thing we want to do, I think it ran fine. I think it ran fine. And then we want to say make dir data. So let's do this next. I guess we can just copy that potentially. There we go, make data. And then we can mount it. So then we do this mount command. But what we do is we use XVDB. There we go. And so now if we do df-h, notice that it's got two volumes, right? Remember it only had this before. So you do have to run a couple like Linux commands, but the reason why this is cool is that I could then fill it full of data, do whatever I'm doing, collect, data science, machine learning, whatever it is I'm putting on here, and then I can always detach it, right? So I could actually unmount and then give it to some other machine or give it to somebody in my team. So it is actually useful to know how to do this. And if we want to unmount it, I forget the command off. Yeah, here we go. Sudo unmount. We just unmount, and we want to get rid of it. We just go unmount. There you go. And now if I do df, it's not there anymore, right? But remember before where we had this, it's not. It doesn't exist. So it's pretty straightforward. There's a couple little Linuxy commands that you have to run, but you can definitely do this yourself by just mounting a volume. And now you could even go here as well and go to volumes. And let's just, since we're here, let's do it. Let's make another one. So we'll go here, and I could say even another EBS volume, and I could say let's make 100 gig volume, right? That's a pretty big volume. And then that looks good. Let's do it. We'll create this volume. And so now that it created it, let's search here. See, look, that's the one I just created. So it's a big volume. And so I believe all I need to do is I need to copy this, go to this disk, to this instance, and then I can say action, and I can just attach it. So let's see, where is this? Create image, instance state. There's definitely a way to attach. Here we go, storage. Let's see, what do? You say, there's definitely a way to do this. And let me just Google it. attach EBS to running instance. Maybe you can't do that. Let's see. Attach EBS to running instance. Let's see if we can do this. And let's see here. Attaches an EBS volume to a running or stopped instance. That looks like what we want to do. And anyway, I won't fool around with it, but they're definitely if I can't figure it out, there definitely is a way to attach it. I won't fiddle with it. You may have to like stop it and then attach it or something like this. But there's a way to do this. I mean, I could try one last thing just so I don't give up, which is I go to volumes and I click on this and I say attach volume. Aha, there we go. So it's the other way around. So the EBS, I have to give it the instance. Oh, see what it says? No running or stopped instances in US East. So maybe I didn't launch this in the right zone. I don't know where this, if we go back to, so I'm going to delete this volume because I don't want to be charged for it. I'm just going to say delete volume. And let's go back to this instance and see where it's running. Where's this thing running? It's running in where is this thing running? Linux. Why is it not telling me which zone it's running in? Networking. US East 1B. Okay, so I just need to run it in US East 1B. So let's do this. Let's go to volumes, make one more. And I'll leave it 100 again. Aha, there we go. 1B. There we go. Let's create the volume. And then we've got it here. Actions. So maybe it takes a second. I think it takes a second to, see, that's the issue, is it takes a second for it to create. So let's let it wait. Let's do the whole thing so you can see this because, okay, it's available. Now we'll go to actions. Now we go to attach volume. And now we should see. If I go back to this instance here, we can grab this And that's the one right there. And look, see, it's gonna give it this device name. And so the same thing I did before where I did all those Linux commands, we're gonna do it again. Let's do it. So we'll attach the volume. Now it's there. Now if I go back and I do the history command, we can see all the commands I ran. So I can do this ls block. This will show us that, there we go. Look, see, there's that 100 gig drive. Right, so if you ever, this does come up in capstones, especially for MSB students, is you're like, how do I get like a terabyte drive or 2 terabytes, or this is how you do it. So now let's just do the same thing we did before, which is let's make a file system here, and then let's make it for this, which would be /dev xvdf. And now all I need to do is we know that the data partition or the directory exists, so I can just mount this inside of there. So I can say sudo mount, and sudo means run it as the root, mount, and we can just put this new dev xvdf here, and then do data. There we go. Now look at this, df-h. We have a 100 gig drive. That's it. And I can just go into there, data. Now it may be that I have to chmod the permissions. So you have to say like, I mean, an easy way to fix this would be to say, chown EC2 user to do data. That might work to do this like that. And then if I do touch, there we go, I can touch. So I'm giving myself the privileges to access it. And then I could even go inside of here, put this is my data or whatever. So you can get access to huge volumes by telling EBS, create one, then attaching it. And then if you wanted to, we could unmount. And let me just look at the history again so I don't forget what I did before. It was, yeah, so let's unmount it now. So I'm going to cd up one here. Let's unmount this. So now it's detached, and if I do df-h, we can see like only this is available. And then if I go back to the volumes and I refresh this, you can see that this volume, now that it's detached, I could do stuff. I could create a snapshot, so I could back it up. So why am I showing you all this? This really is something that's very normal. You could be working with a client. They have a terabyte of data. You're like, how do I get access to it? Well, you just create a volume, attach the volume to your machine. Maybe it's even a spot machine. Do all the work you need to do. Then when you're done, you don't even have to leave the machine running. You detach the volume, and then you could even just go here and you could just do create snapshot. And then once you create a snapshot, you can then have that backed up into S3. So it is good to know how to do these things. I can say force detach here just to make sure it's detached from that machine. And because I unmounted it and I'm detaching it, and I'm also going to go through here because I don't need this volume, and I'm going to be charged for this. And so I'm going to go through here and I'm just going to say basically force detach, and then I'm going to delete it. So I can, it says it's in available state. I might have to do that later. Oh, there we go. I can do it now. Delete the volume. There we go. So I don't want to be charged. Now these, I don't even know what these are. These are probably things I'm being charged for in my account that I, at some point, I should figure out what these are attached to. I think these are attached to like instances I was working on, but these are good examples of maybe me needing to clean up things because I have a lot of credits, but you can be charged for those things. And so then I'm also going to go through and go to instances, and I'm going to go to this instance, and I'm going to say terminate instance. And remember that I told it that when I terminate it, it'll terminate these EBS back storage instances. There we go. So now I've cleaned up all the stuff that I needed to do. So I think that's reasonable demo that I showed for EBS. So here's one scenario, right, which is what I just said. You attach it, do some stuff, and you can create a snapshot. Okay, let's talk about S3 now. S3 is pretty simple to deal with. It's just a big bucket, and you just drop things inside of there. It works well with really large files, media files. Those kind of things work well with S3. The data is stored in objects as buckets, and they can be all over the world. And it says virtually unlimited storage. So you can put an object that has a 5 terabyte file. So I don't know what would be a 5 terabyte file, but maybe like a backup of like an entire company could be a 5 terabyte file, or like high resolution computer vision data, like satellite photos, or maybe like some kind of medical data that might be there. Also designed for 11 nines of durability. So it's basically you can rest assured the data will be there when you need it, and you can also dive in to S3. And so this is actually probably one of the most tricky things to be aware of on S3 that trips up a lot of people on exams, is that it's a whole series of options, and each of them has a different pricing model. So the first one is standard. That's just the generic. And so standard is basically like pretty good. Like it gives you all kinds of really, really great stuff, but it's more expensive. There is something that's kind of interesting that's called S3 intelligent tiering. And essentially, if you enable it, it'll actually figure out what's going on, and it'll automatically move it to the most cost-effective tier. So for example, I think if I'm just reading the instructions here, it says like if there's data that's been sitting there for 30 days and you've never touched it, it just goes, oh, there we go. And it just syncs it up and puts it into a lower cost storage. So I think this could be a really good option for many corporations, Fortune 500 companies or tech companies, is just use this, right? Like if you have data that's just sitting there, it'll automatically go there. Now, if you're really sophisticated, you could also manually use some of these other options, like infrequent access would be, basically a lower cost, or there's one zone infrequent access, which is like the cheapest possible, like S3 storage. It's basically like, look, I don't really need this data. Let's just throw it here and just, let's not spend a lot of money on it. And then there's Glacier and Glacier Deep Archive. And so this is basically like offsite backup. And so you would want to use this if you needed to keep, backups of your system. And then I think the Deep Archive is the lowest cost. And so this would be if you need to retain your data for, let's say, 7 to 10 years, you would put it into the Deep Archive. And so you assume you probably never access the data, and then maybe after 7 or 10 years, it just gets deleted. But just in case you would need it. A few things to remember about Amazon S3 buckets. One is that in order to upload your data, you would need to create a bucket in AWS region, upload anything you want, and then the style of the endpoint is this. So we have Amazon S3, the bucket name, and then what's inside of there. So it's the HTTPS, and then it says S3. This would be where the region is, and then the name of this Amazon AWS.com URL, and then the name of the bucket. Now, the reason why this is important is that the bucket names are actually globally unique. And so this is why sometimes you try to create a bucket and it won't let you create it, is that you are creating a bucket that someone else created in the past. The other thing to be aware of about Amazon S3 is that the data is redundantly stored in the region as well. And so you don't have to worry about it being lost. And then it's also will automatically scale for you as well. So essentially as many requests that come in, it'll just automatically handle. You don't have to worry about like the server being overwhelmed. It'll just scale up and scale down for you. So it works really, really good for things like streaming, movies, right? If you were going to put a bunch of movies onto Amazon S3, no problem. You can also access the data anywhere. So the three most common ways, and maybe we'll go through this in a second, would be Amazon console, the command line, and also the SDK. And I think we could try all three of these so that you understand how these work. And common use cases would be storing things for like a mobile app or something like that. Static website hosting. So I have two different websites that I host on Amazon, and I just throw the data into the bucket and it just makes a website. So it's actually very, very simple for that. And then backup, disaster recovery, maybe staging area. So if you're working on something with Spark, for example, and Databricks, or maybe Amazon SageMaker, if you use SageMaker and you wanted to train some deep learning models, you would actually put this into the S3 location, and then the training would happen in S3. And then when the training's done, it puts the model inside of there. So this is what I would call the data lake, right? So a data lake means that you can process in the same location that the data lives. And that's a really strong use case for S3. So we see this, right? Backup and storage, application hosting, media hosting, software delivery. I've used for all these things. And the pricing is you only pay for what you use. So, gigabytes per month, the transfer out to other regions, put, copy, post, list, and get requests. Those are all HTTP requests. You don't pay for putting the data inside, and you don't pay for transferring it to other related services. So this is something I use. I use Amazon CloudFront, which is a CDN or content delivery network. And I don't pay for that, right? Because it's tied closely with S3. The storage pricing would be, there's just different classes, right? I was just talking about that. The standard storage is 11 nines of durability, 4 nines of availability. The standard and frequent access is slightly lower availability. And you're also charged by the number of and size of the objects, the requests you make, and then the data transfer. Those are all the different ways you're charged with S3. And so, again, should know all these things. It's a fully managed service. It can store unlimited data. You pay for what you use. You can access it anytime. And so let's do it. Let's go for a demo. So let's go into S3 here. And what I'm going to do is I'm also going to open up Cloud9. So my recommendation for students is that you get very comfortable with Cloud9, because for many things that you do as a student, Cloud9 will help you out, especially with dealing with things like S3. So I'm going to create an environment here. I'm going to say AWS Cloud9 environment, right? And we just put some notes in here. This is for my capstone project. Here we go. And then I go here, next step. And I always like to get a slightly bigger instance so it's performant. And I have credits to use. We'll go ahead and do this. And so while this is spinning up, I'm going to go back to the console here, and I'm going to go over to S3. So that's our storage location. And with S3, a couple things that we can start off with is, let's just create a bucket, right? That's a good spot to go. I'll go ahead and create a bucket. And you can see here, this is the process. It says, all right, bucket name must be unique and cannot contain spaces or uppercase numbers. And then we have different regions that we can put it into, like US East, West, whatever. I'm going to say US East, that's fine. And we'll just call this today's date. So we can do February, it's Valentine's Day. We'll say Valentine's Day 2022. Probably that bucket name is available. And then I can just leave all the defaults. Now, if I was going to create like a website, you could actually unclick this, and you could actually create a website that people could go to. You can also do this, which is pretty neat, is it can do auto version control for the files that you have in your bucket. And then also, if you needed to, you could automatically encrypt your data into the bucket as well. So some pretty awesome features that come up there. You could also do things like lock objects. Like there's a lot of advanced features. So let's go ahead and create this though. We have a Valentine's Day bucket, pretty cool. And then if I go to this bucket, it's very easy to put data inside. So how would I do this? Well, let's just take a snapshot of something. I'm gonna do like a screenshot of my screen. So I'm gonna just do like a Shift Command 4 and make a snapshot of some data, like a screenshot of my screen. And then I'm going to just drag that screenshot into here and just throw it in there. So we just see how to put data inside. That's it. We just drop it in there. And then we can see where it goes, upload, just like that. There you go. Really trivial to actually drop data down there. Now, let's go back to our Cloud9 environment to see how we could actually interact with it. So this is a really cool little interface that many people aren't aware of. Is again, if you need to access all this really big data, you saw it's pretty simple. Make a bucket. It can keep unlimited storage, but you also can go to Cloud9 right here and click on AWS. Look, see, it says US East. Go here, go to S3, and then inside of S3, we can go down here and we can find Valentine's Day. And there we go, Valentine's Day. And let's take a look. Look at that. There's my screenshot, right? And so I can actually right click here. I think I can work. How can I can right click on it and I can just say download. And I could just download this and I could put it into my Cloud9 environment here. And there we go. Now I just put it right into my environment, right? So now I could, let's just rename it, make it clean, easier, just say like image or something. And I believe I can even so look, we can even take a look at it inside of here. Like I just took a picture of my slides, right? So pretty cool round trip, right? I can put stuff in there and I can do the opposite as well, right? So I can also do the opposite round trip, is that I can communicate as well by making like a file inside of this environment. Let's just make a file like a hello world Python file or something like touchhello.py. And then I'm going to double click on it and let's just do something like, print hello. Let's go through here. Let's make sure. I don't know why this thing is, I'm going to reopen it up again. It was freaking out. Let's just go to Cloud9 and go to S3. Is it this one, large? Got too many environments. Big environments. Where's my S3 environment? I wish there was an order where it told me which environment was which. Containers, Cloud9 environments. I'm just going to be lazy and just pick one because I don't want to wait. Because it doesn't matter. Oh, I picked the right one. So basically, if I just go through here, there we go. I can just say prints hello. And we'll just run this Python hello, right? So you can just put regular files there too. So we can go here, go back to that bucket, go to S3, find our Valentine's Day, and I can just say upload files, and I could just grab this file, and I could just right click and just upload it as well. So you can go. There's a nice round trip here, and now keep in mind that I also can upload data from my desktop into Cloud9. So this is another kind of a cool thing to be aware of, is I can just go here and just right click and just say, I don't know, like, where's this? Or no, file. You go to file, you say upload local files, just select some file on my desktop. I don't know, like, here we go. Here's some picture of something I was just working on. There we go. And then this is here, and then I could go back to here and right click and then say upload and then put this in there. And so if we go back now to S3 and we refresh, we should see all these files. So let's close this. There we go, right? We have 3 files. And then I could do the same thing. I could just go through here, right click on it, download it. You can also copy the URL. So like if I wanted to get the full URL to this thing and do something to it, that could work. And then you could also share with a pre-signed URL as well. So you can actually give these like temporary URLs to people. Another thing you can do S3 is also query. So you can actually query a file and retrieve a subset of the data. So if you had some kind of, I don't know, big data set or something like that, you could also upload it and then do a SQL query on top of it. So, and here we go. Here's actually the SQL query. So there's a lot of really cool stuff inside of here. My recommendation would be using like Cloud9 plus S3. You're in the console, you pretty much can do anything you want. Now you can also, I'll show you one last thing you can do with S3 is you can do this. You can do AWS S3 LS. You can also use the command line and you can communicate with it. And you could just do AWS S3, I think it's sync, and you can sync even whole directories back and forth, which is pretty cool. Another thing you can do with S3, this is the SDK, is you can just pip install Boto3. So let's do that. So let's say Python 3-m venv. This is a very common thing that people do is they programmatically talk to S3. You source it here, bin activate, and then we say pip install Boto3. And then typically what I like to do is I use a tool called IPython. I would say pip install IPython, and then I would just kind of programmatically access S3 via the Boto library, which is the SDK. So I would say IPython, and I would say import Boto3 like this, and then I just look up the documentation. So I just say, like Boto3, here we go. Let's look at S3. Just find some kind of S3 example, code examples, S3. How about, where's an example? List a bucket. That's what we care about, right? Let's just do that. So I'm going to go through here and I'm going to say, first thing is make an S3 client, and then go through here and then say list buckets, response. There we go. And if I go to response, there we go. There's my buckets. So we should all 3 ways: console, the ability to use the SDK, and also the command line tool. We actually showed 4 ways, and also how to use this development environment. All right, that was a good demo. Okay, next up, let's talk about Elastic File System, which is pretty cool. It's definitely one of my favorite utilities because it basically allows you to just mount this onto a machine and you can just grow it up and down. And so Elastic File System allows you to auto shrink and grow. So you don't even have to provision it, which is really neat as well. So it works with AWS in the cloud. It works well for big data analytics, media processing, content management, web serving, home directories. It can be petabyte scale as well. So if someone was asking you as a consultant, again, maybe a capstone project or consulting client, hey, we want to have a bunch of machines in AWS all talk to the same data source and access it as a file system, and we have petabyte scale data, well, you would use EFS. EBS doesn't talk to all the machines, right? without doing more tricks like creating a file server. EFS just by default, you can just have everybody talk to it. So it's a shared storage system, and it uses a protocol called NFS. So it basically supports the NFS file system. And so that just means that you can use it as like a network file system, and it's compatible with all the Linux-based AMIs. So how does it work? Well, you would create a VPC, maybe have an availability zone here, like 3 availability zones, and then you have all these mount targets, and the Elastic file system can talk across all of them. And the way you would do this is you would create Amazon EC2 instance, launch your EC2 instance, create your EFS file system, create your mount points, connect to the EC2 instances, to the mount targets, verify the resources and protection of your AWS account. And then here are the different aspects of it. You have a mount target, you have security groups, you have one or more per file system. You can create it in a VPC subnet, and then there's one per availability zone, and they must be in the same VPC, and you can tag it as well. You could add like metadata about the VPC. So these are the big takeaways. File storage over network, great for like media companies or people that need to talk to a lot of data all online. And it's fully managed, so you don't have to worry about like doing any kind of file server management, and it scales up and down automatically. So we could do that demo. Trying to think about this. Do we want to do Elastic File System demo? It might be a little much, a little too technical. We can just skip that one. So let's talk about Glacier next here. So Glacier is data archiving. So this is a very common problem in corporations. They need to have access to data, backups, and they want to make sure that things are secure, durable, and you don't want to spend too much money. And so a thing like Glacier is actually pretty nice because it allows you to do all this via AWS, and it supports encryption. So it's encrypted as it's going through the backup. And believe it or not, this whole encryption in transit is still a fairly non-pervasive technology. Like a lot of the chat clients aren't encrypted. I know there's back and forth about it. So that means like someone can intercept everything you're doing in a chat client. But in this case, it's encrypted end to end. So someone couldn't get in there and get your data in transit. The Vault Lock enforces compliance through a policy. It's extremely low cost. It works well for long-term archiving. It provides 3 options for access to the archives: expedited, standard, and bulk. And the retrieval time is a few minutes to actually several hours. And in terms of the Glacier service, you can configure the lifecycle policies to automatically move the data to Glacier. So that's actually a pretty cool feature of S3. If I go back here, I think I can just do this. If I go to this Valentine's Day folder and I go to properties, see, I could do this. I was talking about earlier. I could do intelligent tiering archive. I could just go through here, create it, and it would automatically kind of watch what's happening and make it go to the correct storage system. But you can also do, where is this? You can do static website hosting, but there's a lifecycle policy, which is at management. Here we go. It's under management. You say lifecycle rule. So you say create lifecycle rule, and then, I don't know, we call this tests. And then you could basically say, I want to move the current versions of the object between storage classes. And then basically we could say, listen, I want you to go to, I don't know, intelligent tiering after 1 day, right? Like I want you to go to this one. And then I could do another one. And I could say, once you're in one zone A, I want you to go to, I want you to next go to, after 2 days, I want you to transition here. So you could basically create all these different, ways of dealing with the data. You can say delete expired object, permanently delete non-current versions of objects, expire current versions. Like you can set all these rules up that allow you to kind of transition the life cycle of your project. And it may be the fact that it's not just even the cost. It could be a requirement of your organization, like a HIPAA requirement, or a government, like a American military requirement or something like that, that you may have to do some kind of life cycle policy. So it's important to be aware of this. And in terms of use cases, media asset archiving, that's a great one. The healthcare information archive is another one. So this could be very critical. Like maybe you need to keep track of patients' records for cancer or X-rays or any of that kind of imaging. And so there may be like a requirement for you to keep track of that data, and you need to store it off-site somewhere for like 7 years. And then after 7 years, you can get rid of it. Regulatory and compliance, maybe you're working in legal, right? And you have some form of requirement to keep track of things, or you're, I don't know, in the White House, right? That's a big issue right now, is like all of the presidential communication, maybe it needs to automatically go somewhere. Scientific data archiving, let's say you're working on drug discovery or genomes or something like that, you may want to make sure that it's stored somewhere so that you always have the copies of it. There's a lot of use cases for basically keeping data somewhere just in case you need it, because it could be an existential threat for your business. So it's boring. I know many people probably aren't interested in data archiving. It's boring until you need the data, and then it's not boring anymore. And I've been there. So Amazon S3, Glacier, how do you get to it? Well, you can access it via a RESTful web service. That's one way to do it. You also can talk to it via SDKs like Boto3. You can also do Amazon S3 with lifecycle policies. That's another great way to access it. So Amazon S3 lifecycle policies enable you to delete or move objects based on the age. I was just talking about that. You could just say, okay, after 30 days, let's move it to the cheaper one, which is the infrequent access. Then after 60 days, move it to our archive. And then let's just leave it there for a year. Once it's there for a year, we could just delete it because we're good with that. So storage comparison here, we have in terms of data volume, there is no limit. You can store an unlimited amount of data in both the S3 and S3 Glacier. The average latency for S3 is milliseconds, but for Glacier, it could be minutes to hours. So it's not fast. The item size would be 5 terabytes maximum, or in the case of Glacier, it could be 40 terabytes maximum. The cost in gigabytes per month would be higher cost for S3, lower cost for Glacier. Build request, you can see you're only billed with Glacier with upload and retrieval. Retrieval pricing, you're charged by the request and also by the gigabyte. And so when you retrieve the data, notice how it's more expensive for Glacier. So server-side encryption, you can see it's completely encrypted end-to-end everywhere. And your application must enable server-side encryption as well. And then what are the ways you could secure your backup data? So this is another thing to be aware of, is just because your data is in back offsite storage, it doesn't mean like, okay, yeah, great, everything's great, we're in offsite storage. Well, you need to control who can access those records, right? There could be a bad actor that gets into your archives and fiddles with it and either deletes the data or steals the data, right? And so that's why the IAM is so critical. That's the account management system, is you make sure that only the correct people have access to the data. And in fact, that the data has proper data governance. Also, is the data encrypted? And then are you actually making sure that it's automatically handled via the backup system where S3 Glacier can manage your keys for you? So takeaway is that Amazon S3 Glacier is a data archiving service that's designed for security, durability, and extremely low cost. Amazon S3 Glacier pricing is based on the region. It's extremely low cost. So it's basically built for archiving, and it's highly available.